Alright, so a quick little reminder of what we did for probability. In the first box, we sort of talked about assuming that we didn't stop on a black line, what was the probability of getting the blue color, and many people got it as 1/4. And then we spoke about, well, how we get the 1/4. People said, well, the 1 comes from the number of ways you can get a blue, and the 4 comes from the total number of ways you could get a color. So that's the basic probability for equally likely outcome events, the basic formula. Then we defined a couple of terms. We defined probability model as having two things, a sample space, and then assigning all probabilities to that. So then we spoke about what a sample space actually was. Okay, and so the sample space is the set of all possible outcomes. Sample space is a set of all possible outcomes, and in the previous example with the spinner, we could get a red, a yellow, a green, or a blue. So that's the sample space for that problem. An outcome is just a particular element in that sample space. So like an outcome could be like getting a green, That's an outcome, or a red, or whatever you want. And then an event is the set of all possible outcomes, or sorry, not all, it's the set of possible outcomes, like getting a red, okay? So a couple of terms there: probability model, sample space, outcomes, and event. Then we constructed a probability model for rolling a fair die one time. The sample space is 1, 2, 3, 4, 5, and 6, because each of those are equally likely events, and those are all the possible outcomes of rolling a die, assuming we don't throw it up against a wall or something like that. If we assign each outcome a probability, well, the probability of getting a 1 is 1/6. Probability of 2 is 1/6, probability of 3 is 1/6, and then all the way down, of course. And if you add up all the probabilities, they sum to 1. And that's always going to be the case when you're creating a probability model. So probability is somewhere between 0 and 1. Alright, that's a probability model. Okay, then we constructed a probability model for tossing a fair coin 3 times. So on the first toss, you have two choices. You can get heads or tails. On the second toss, you have two choices. You get heads or tails. And then finally, on the third toss, you have two choices. You can get heads or tails. So the multiplication principle says you multiply all these together to get a total of 8 outcomes. Then we listed all of the outcomes, starting with head. So head, 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 tails, head, tails, head, tails, tails, head, tails, tails. And then everything with tails. And each of these probabilities gets 1/8. And of course, they sum to 1. So this whole entire thing that we did collectively is a probability model. Okay, then I talked about the very, very important things about the difference between and versus or. And means multiply, or means add. Then we went on to talk about the spinner problems. And I gave you an example of, okay, we have 3 spinners, spinner 1, spinner 2, spinner 3. And then I think I did, what's the probability of getting a B or a D and a blue or an up? So I think what we did was we found the probability of blue, found the probability of, probability of B, probability of D, probability of blue is a third, probability of up is a half. So we said B or D, so we added those probabilities together, 1/4 plus a third, and blue, multiplied times that, and then or up. And then we added finally the 1/2, and then I think we got 2/3 as an answer. Okay, this should set you on the right path, and we'll talk more about it on Monday. Okay, sweet.